Hi, I'm Wes Wolfenbarger, Application Engineer with TriMech. Welcome to this TriMech training series. In this series, we are going to walk step by step through a workflow that converts this 2D print into a 3D model. Throughout the course, you will see that the design communicated by a 3D model is both bold and clear. We're going to create this 3D model and 3D drawing. We will begin by importing an engineering drawing into SolidWorks. We'll get the part modeled in no time using the 2D to 3D toolset, and we will communicate our design and manufacturing needs using the DIM Expert. Finally, I will show how to produce both a 2D and 3D PDF. I'm ready to get started, so let's begin. I want to show you how easy it is to use both DXF and DWG files in your 3D modeling projects. Let's start with this drawing. SolidWorks makes it easy to explore our 2D file data in the import wizard. Edits are simple, and with a couple of clicks, we easily remove all unwanted geometry from the sketch.
In SolidWorks, begin by opening a DXF or DWG file. The import wizard opens. Select the following two options: Import to a new part as, and 2D sketch. Click Next to edit import settings. We are only interested in importing layers that contain model geometry, in our case layer 0. I will turn the other layers off. The settings control imported units, dimensions, and layers. Layers can be imported into unique sketches. Click Next. We will leave the mapping settings alone. Click Finish. Using box selection, highlight only model geometry, select invert selection, delete. This removes unwanted sketch geometry.
You just saw how quick and easily you can reuse 2D engineering assets. That wraps up this tech tip. Follow our progress in the next episode. In the next episode, we will explore the SolidWorks 2D to 3D toolset, taking our project from a flat sketch to a 3D base layout. I want to introduce the SolidWorks 2D to 3D toolset. In the last episode, we saw how easy it is to get our 2D assets into the SolidWorks design space. What a great tool! Taking it a step further, we will reorient and align our sketches. Before we begin, let's take a quick moment to set up our workspace. Make sure the 2D to 3D toolbar is turned on. We will also activate our DIM Expert tab and optionally the MBD tab if you have it.
After looking at the print, I realized that SolidWorks interpreted these fillets as splines, not ideal for dimensioning. Using Extend and Trim, I get the corners I want. Trim out the splines, and I will add a fillet feature later. Add a center line to our bottom view sketch. We'll use these center lines for alignment. Select the following geometry. This is our front view from our drawing. Let's assign the sketch entities to the front plane. Click on the Add to Front Sketch button on the 2D to 3D toolbar. The sketch entities turn gray to indicate a plane has been defined. Use the same technique as before. Select the right view, sketch, and add it to the right plane. Notice the sketches are not aligned. We want to move the right sketch to align with our front sketch. Select the right sketch centerline and Control select the front sketch centerline. With both selected, click Align Sketch. The right sketch moves. This is because we selected its centerline first. We'll do the same steps to get the bottom view in position and aligned. This process results in 3 aligned sketches in 3 different planes.
Wow, that was hassle-free. Reusing existing CAD assets is a great method to save time and reduce mistakes. That wraps up this tech tip. Follow our progress in the next episode. In the next episode, we're going to bring this part to life. As we are modeling, I will be offering design tips and best practices when modeling from an existing dataset. So far, we have imported a 2D drawing, positioned the aligned sketches for the part. We are ready to bring this part to life. In this episode, we explore some design techniques that will aid in transforming these 2D sketches to 3D models. Let's get started.
Begin by using the Contour Select tool. Select the closed regions that create the head geometry. Omit the set of circles in the selection. Once the selection has been made, we will use the Extrude Base command. Extrude in 2 directions, both with up to end vertex conditions. We select the vertices that define our yoke width from the sketch on the right plane. This dimensionless technique will preserve the integrity of the original DWG file. Let's cut out our rectangular slot through the yoke base. Using Contour Select, we select our rectangular profile from the right sketch. Select Extruded Cut and use a Through All End condition. We need to add a threaded boss to our yoke. Using Contour Select, we select our large circular profile from the bottom sketch. Notice the bottom sketch is not aligned with the right vertex. We can accommodate this shift by using a From condition. Select Vertex from the drop-down and select any point on the bottom of the right sketch. Notice the preview updates. For End condition, select Up to Surface and select the bottom rectangular face of the yoke base. Verify the boss creation, click OK. I want to add a M14 by 1.5 threaded hole to my cylindrical boss. Using the Hole Wizard, we can place threaded features that contain manufacturing information into our part. Begin by defining the hole position. Select the bottom face of the cylinder to constrain the sketch. Hover over the boss's circular edge and wake up the center point. Click the center point for the hole position. Next, select the Type tab to define our hole. Here we will define our hole geometry. Use a straight tap hole. Select the ISO standard. Define an M14 by 1.5 hole. The end condition will be the drill tip vertex selected from the right sketch. Verify thread end condition is set to 2 times diameter, which is 28 millimeters. Set the following options: cosmetic thread, with thread callout, and near side countersink. Click OK. I like to make use of the design library for common features. One common feature I use for turn parts is a shaft undercut. Apply the library feature by dragging it from the design library and dropping it onto the rectangular face. To fully define the library feature, we need to select the missing reference edge. The pop-up window highlights a clue. Select a similar edge and My Geometry updates a preview of the feature. Use 4 mm for the undercut width. The cylindrical boss requires a thread. This thread is an external thread. Using the Cosmetic Thread Annotation tool, we can add manufacturing information to our design. Select Insert, Annotation, Cosmetic Thread. Select the leading edge of our cylinder boss for thread settings. Define the Start From face plane by clicking on the end face of the cylinder boss. We will use M33 by 2.0 external thread. This thread standard can be found under Machine Threads within the ANSI metric options. We will set the end condition for up to next. The cosmetic threads did not show up on our part. To see the cosmetic threads, right-click on the Annotations folder in the feature tree. Click Details. The annotation properties display. Select Shaded Cosmetic Threads, select Apply, then OK. We have done the bulk of the model now. We just need to add the finishing touches. Using a chamfer feature, add a 2 mm by 45 degree chamfer to the outer perimeter of the yoke edge. I will do this for both outer edges. The leading edge of the threaded boss will also get a 2 mm chamfer. To complete the geometry, we will add the 2 mm fillets back to the rectangular slot that we removed in episode 2. Our geometry is complete. To finish, we will define a material for the part. We want to use AISI 4340 steel annealed. To apply this to the part, right-click on the material in the feature tree and select Edit Material. Within the Materials dialog, pick the steel drop-down and select the material AISI 4340 steel annealed. Click Apply and close.
Fantastic! Seeing our model in 3D for the first time really communicated the design. Instant visualization gives designers insight to additional requirements that were not obvious in the 2D drawing. That wraps up this tech tip. Follow our progress in the next episode. In the next episode, the engineering team has decided to make a slight variation to the design. We will discuss managing this variation with configurations. Thanks for watching. In the last episode, we modeled and detailed our yoke. We took it from 2D to 3D. It is becoming more commonplace to see computer simulations on parts. They are far safer and more cost-effective when compared to conventional prototyping. Let's use SolidWorks to create real threaded geometry to be used by our design team. Let's begin.
To begin, we will create a new configuration. Configurations are a great way to manage parts that are similar with slight variations. Click on the Configuration Design tab at the top of the Feature Tree Manager. Right-click on the model name and select Add Configuration from the pop-up. Name the configuration Sim Model. Click OK. A useful tip when working with configurations is the Feature Tree Splitter. Grab and drag the bar at the top of the Feature Manager and 1 become 2. Using the Thread feature, we can model threads quickly and accurately. Click the drop-down on the Hole Wizard button and select Thread. We choose our thread starter edge, the edge between the cylinder boss and chamfer. Select Offset. The offset serves as a lead in and lead out of the thread. Set it to 11 mm. Use a blind 55 mm end condition. Specify a metric die, size 33 by 2.0. Select the cut thread method. Right-hand thread should be selected. Click OK. Our new configuration is complete. To toggle between configurations, double-click on the configuration name to activate it.
Wow, that threading tool is really cool. Now we have a model ready to give our design team to do a computer-aided stress analysis. Configurations are a great time saver and a great way to manage similar parts. That wraps up this tech tip. Follow our progress in the next episode. In the next episode, we will add dimensions and detail to our part for manufacturing. I will be introducing DIM Expert. This intuitive detailing tool is sure to speed you up. Thanks for watching. In the last episode, we set up a part configuration for our simulation team to test. In this episode, we are ready to prepare the part for manufacturing. Typically, this involves the production of a 2D drawing. This is our challenge, to eliminate the centuries-old 2D paper drawing and replace it with a modern digital 3D drawing. We begin our 3D drawing with DIM Expert. Let's take a look.
To show the DIM Expert command tab, right-click on the Sketch tab, then select DIM Expert from the pop-up. Begin by clicking on the DIM Expert Design tab at the top of the Feature Manager. Click the Auto Dimension Scheme button. we have a few simple options for the dimensioning setup. Select the following options: prismatic, set the tolerance type to plus minus, and linear dimensioning for patterns. It is possible to select up to 3 datums per dimension scheme. Select the following. Primary datum will be the top of the part. As a note, you can right-click between datum selections and it will jump the selector to the next datum input. Next, the secondary datum will be the inside slot face. Set the tertiary datum to the cylindrical boss. To fully define our part, we will set the scope to all features and select all in the feature filter list. Select OK. Notice the part is highlighted green. This is because the tolerance status is set to show. The green indicates the model geometry has been fully defined by DimExpert. DimExpert dimensions appear in pink. All DimExpert views are managed within the annotations folder. We could see there are 6 views in the annotation folder. Our drawing only had 3 views. We need to do some consolidation. When consolidating dimensions, use the tilde key to display the change the annotation view pop-up. Use by highlighting the dimension that needs to be reassigned. Click the tilde key and select the correct annotation view. It is important that all of our DimExpert dimensions appear in the correct orientation. The layout of the dimensions in the part model will be replicated in the paper drawing. To set and modify dimension placement, go normal to the annotation view by right-clicking and selecting Activate and Reorient. Move the dimensions around until you get the desired aesthetic. Make any necessary changes to both the front and right views. If dimensions were moved or removed, it is always good practice to double-check the tolerance status.
DimExpert is a powerful tool that dimensions parts using the virtual geometry. With DimExpert's intelligent design features, fitting DimExpert into your workflow should be an easy transition. That wraps up this tech tip. Follow our progress in the next episode. In the next episode, I will show you how to use the details created with DimExpert on a standard 2D drawing. We will create a fully detailed 3-view drawing in seconds. Thanks for watching. In the previous episode, we captured all of our product manufacturing information with our DimExpert tool. Now, let's use that information to share our design with our machine shop. We will create a 2D drawing quickly and accurately by reusing our DimExpert details. Let's get started.
With the yoke model open, select File and select Make Drawing from Part. Select an appropriate drawing template. Open the View palette by clicking the View palette icon. We want to check the following options: Import Annotations, Design Annotation, DimExpert Annotations, Include Items from Hidden Features, and Auto Start Projected View. Notice the A in front of the 3 drawing views in the View palette. This means there are annotations associated with those views. Drag and drop the front view from the View palette. Drag a projected view to the bottom, and then drag a projected view to the right. There are a few dimension locations that I want changed. The thread depth will look better in the right view with hidden lines visible. Hold down Shift and click the 28mm dimension and drag it to the right view. All of our new dimensions and tolerances reflect that which appeared on our original DWG. Everything looks really good. I just want to fine-tune the placement on the paper and I'm ready to save this drawing and publish to a PDF.
It's easy to see why DimExpert is gaining popularity. We created a 2D drawing from scratch in about a minute, and that's a relief because working with drawings all day can be tedious. That wraps up this tech tip. Follow our progress in the next episode. In the next episode, I will show you how to use the details created with DimExpert to create a 3D drawing using SolidWorks MBD. We will create drawing views, work through the 3D publisher, and finally, create a 3D PDF that is fully dimensioned and ready to use. Thanks for watching. In the previous episode, we created a 2D drawing in a matter of minutes by reusing the DimExpert details. In this episode, we will make use of the same DimExpert information, but we will be presenting it in a 3D format. I will walk you through the process of creating drawing views and publishing your 3D drawings. Let's get started.
To show the SolidWorks MBD command tab, right-click on the Sketch tab, then select SolidWorks MBD from the pop-up. Enable SolidWorks MBD command tab on the Command Manager. Activate 3D Views tab to enable the 3D Views palette. Set the view to ISO. Click on Capture 3D View. Here we can create snapshots of both views and annotations. The first view we create will be an ISO view, with all annotations visible. Name the 3D view All. We will keep all annotations selected for the ISO view. Click OK. Next, capture the following 3 drawing views: bottom, front, and right. We begin by activating and orienting our front annotation view. Adjust the preview so that all dimensions are visible. Click on Capture 3D View. This view will be the front view with only front annotations visible. Name the 3D view Front. Select only the front view annotation. Click OK. Activate and orient the right annotation. Adjust the preview so that all dimensions are visible. Click Capture 3D View. This view will be the right view with only right annotations visible. Name the 3D view Right. Select only the right annotation view. Click OK. Next, activate and orient the bottom annotation. Adjust the preview so that all dimensions are visible. Click on Capture 3D View. This view will be the bottom view, with only bottom annotations visible. Name the 3D view Bottom. Select only the bottom annotation view. Click OK. We want to add a section view to our print. 3D prints can accommodate a section view. The sections appear as expected with slices removed from the model. Click Section View on the MBD toolbar or the heads-up display. The front plane will be our cutting plane. You can hide annotation views by right-clicking on the view name and selecting Hide. Click on Capture 3D View. This view will be the selection view with only front annotations visible. Name the 3D view section. Select only the front annotation view. Click OK. Remain in the ISO view from the section view. Turn off the section view. Right-click on Annotations and uncheck Display Annotations. Click on Capture 3D View. This view will be an ISO view with no annotations visible. Name the 3D view Threads. Select the Sim Model configuration from the drop-down. The front annotation view remains selected, though no annotations appear. Click OK. We are now ready to publish this 3D print. Click Publish to 3D PDF. Within the publisher, we can select our drawing templates and select what views to publish with the PDF. Make sure all 3D views are selected. Use the Simple Part A4 landscape layout. Click the blue next arrow. Click the Edit button. Here we can link custom properties to fields that display in the PDF. I will set the following custom properties: date, part number, revision, and material. And I will add some custom text to the comments and designer fields. Click Close. Click OK. We just need to set our path and we are done.
Once again, it's easy to see why DIM Expert is gaining popularity. We created a 3D drawing from scratch in a couple of minutes. We can share this with anyone that has a PDF reader, and they too can appreciate our design. That wraps up this tech tip. Thanks for spending time with me going through this series on 2D to 3D. It has been a great experience answering your questions and emails. I value your comments and suggestions, and if you enjoyed this and other TriMech tech tips, check out our full-service instructor-led classes at TriMech.com. Sign up today and experience the TriMech difference. I'm Wes Wolfenbarger. Thanks for watching.